With the workflows inside Roboflow, we can actually go in and set up a whole computer vision inference pipeline. It's just a drag and drop UI where we can take the different components, connect them together. We have our input image. We can connect them to different layers. Could be an AI model. We can have visualization layers, different condition layers, and so on. We can even hook it up to foundation models, large language models, and so on. So in this video here, we're going to take a look at the Roboflow workflows, how we can use the templates out of the box, and also how we can create our own custom workflows. Then we basically just create it inside the UI. We specify all the things that we want. We export it. We can then deploy it either on the hosted server, your own local cloud, or you can actually deploy it on your local machine as well. It's just a few lines of code. We can connect to the inference pipeline, specify where you want to run it, live webcam, video, or whatever. So let's not just jump straight into the Roboflow platform. I already have a lot of videos covering like pretty much everything in here on Roboflow, how we can take our own custom data set, how we can train our own model, and so on. So this is really easy. We can both use it for data labeling. You can train your own models in there, export them, deploy it, and so on. They also have a very cool feature if you want to find public available data. Maybe you can use it in your own application and projects. You might want to find some inspiration, or you basically just want to test out some different computer vision systems. So basically just have this Roboflow Universe. We can go down and choose object detection, classification, and so on. So right now I'll just take all these. Has a model, so if there's actually like a model available already, you can use that out of the box for a specific data set. So Roboflow Universe projects, they already have some out of the box, both for vehicle model, they have for rock, paper, scissors, they have the football player detection system. Right now, let's just go in and take this construction site safety. There we go. We can see all the different classes. So we detect mask, ladder, safety mask, trailer, sedan, and so on. We see the metrics for an already trained model. We can use that out of the box. You can also fork the project if you want to apply some different stuff to the dataset. Could be different augmentation steps, pre-processing steps, or just add more data. You can try the model directly, or we can just go in and grab it and use it out of the box. So if you scroll a bit further down on the documentation, we can see we can run Roboflow Inference. I'm creating a whole playlist, whole tutorial with all the different tools, things you can do on the Roboflow platform, but also with the open source tools, with the Inference SDK, supervision for visualization, and all that. If you scroll a bit further down, we can then see we have code snippet for hosted API, on device if you want to run on device native SDKs, cloud, and utilities. If you want to run it from the command line, Docker, or RTPS stream. We're going to cover all of it in future videos, so definitely make sure that you are subscribed to the channel, hit the bell notification so you get notifications when I upload new videos. But everything is pretty much just covered here. If you want to use it, we can just copy paste it, so we can just grab it. Let me just open up a code editor before I show you how we can set up the workflows. So just have a bunch of new stuff here. Let's just go in and say, so I open up my code editor here. Let's just go in and create a script called test Roboflow.py. There we go. Let's zoom in a bit. We'll just throw in this directly. We have the API key. So here you just need to specify our API key as well. Then we can pass in our video for a construction site. We can also specify a 0 if you want to run it on our webcam. Or if we have RTPS stream, we can also directly connect it in here. From the model ID, it's going to pull this model automatically. If you have your own custom model and so on, you just need to specify your model ID and API key, and it's going to take care of all of it. So now we can just go in and save this code file, run it. Again, we have this inference pipeline, which is the main thing. It's going to start the pipeline, so it's going to run a background thread. Everything is synchronized. If you have multiple video streams, it handles all the video loading and so on. So it's basically just the best that you can get. If you deploy it on any system, like if you have CUDA device, it's automatically going to set it up for that. CPU, MacBook, Jetson, and so on, all of that is supported. I definitely recommend to set it up with Docker, which we're going to cover in a future video. Then we can just talk back and forth. It will basically just be an endpoint. So we're just talking back and forth between our Docker container and our application. So just run this test_Roboflow. There we go. Let's see if it opens up the webcam. It should pull the model directly just from the model ID. Probably just take a few seconds here to start with. Try to rerun it. It is making a request to Roboflow. And on prediction, it's going to print the boxes. So it's basically just going to take the bounding boxes, display them in the UI. We can also have another callback function where you can extract the results, use it in your custom applications and projects, as we're going to see once we pull up the workflows. So for some reason here, it takes a bit longer. Could be because of the API key and so on. So while it's loading here, let's just jump in and see the workflows. So on here to the left, we have projects. You can create a new project, object detection, classification, intersegmentation, key point detection, and so on. So you can basically just create a new project, do the labeling. Once you have that, we can create our workflow. Even just workflows, you can use the pre-trained models out of the box. They have different templates that you can use, both for object detection, intersegmentation, multi-label classification, and so on. Now it actually started the video over here, so just drag it over. So you can see no mask, no hard hat, person, and also no safety vest. It looks pretty good when I'm moving around here. Looks very smooth. It pretty much gets all the detection, even though you can even see the top of my upper body. No mask, no hard hat, and we're detecting a person. Even when I'm moving around, you can see how fast it is. This is running on a CPU. So this is pretty awesome. Let me just pull up my code editor again. Right now it's not using CUDA or anything. It's running on a MacBook on CPU, and it works very fast. So let me just move around here. Like again, you can detect multiple people and so on. You can raise alerts, triggering and so on if people are not wearing a hard hat. It just took a bit of time here to pull the model the first time. Let me just try to run it again, and it should be faster. There we go. Now we can see it pretty much opened instantly. I should be able to see it connects to my webcam in a second. There we go. And now I can pull it over here. So this is pretty cool. It's just going to call this callback function. You can also have a custom callback function where you extract the results and so on. But we're going to see that once we have our workflow up and running. So let's jump back in here again. Build my own template. Detect, count, visualize. So this is just a whole pipeline. Could also be that you want to do Sachi, divide it into tiling windows. We have videos like covering all of it, so definitely just make sure that you check out those videos. Background removal, active learning, line counting, time and zone. If you want to track how long people are in a specific zone, I'm going to cover these templates, how we can use them, what it can be used for, and so on in future videos. You can do it for intersegmentation, classification, multi-label classification, and so on. Right now I'm just going to create a custom workflow from scratch. There we go. We have our input, which is just going to be images, can be image, video stream. We're just going to load in images from the video stream. Could also be a live webcam, as we're running on now for the other application. We can now go in and add a block. You can share workflows, you can deploy it, test the workflows and so on. But here we have all the different blocks, logic and branching, data storage, notification, video, transformation, classical computer vision, advanced, and we can also have custom blocks. So let's say that we want to send a notification once we detect that we're not wearing the required PPE requirements, or it could be any class, could be any model that you're using, could also just be a pre-trained model out of the box. Then we can go in and send different alerts, send e-notification, Slack notification, or a Twilio SMS notification as well. Let's now go and grab a model. Let's just take an object detection model. It works the exact same way for any of the other ones. We can even have the large language models connected to it. Let's say we want to create a license plate recognition pipeline. We take it, detect cars. We have another model that goes in and detect the license plates. Then we take the bounding box of the license plates, send it into one of these APIs with vision capabilities, and they will be able to extract or do the OCR part and extract the act like numbers and characters. All these are available. Gaze estimation, already have a video about that, but let's just grab an object detection model. So now we'll load all the models that I have on mine, and we also have public models. So if you want to use YOLO8, YOLO11, V11, V10, people detection, vehicle detection directly out of the box. So right now let's just grab the newest YOLO11 model. So let's hit save. Then we can see we have this stuff here over to the right. We have our model name, input image. So there will be an image. We can specify the model. You can change that as well. We can set a confidence score for a prediction. So let's just say 0.4. There we go. Class filter if you only want to detect a specific classes. So right now could be 0 for a person if you only want to take that from the Coco data set. Right now, let's just take all classes. We can have active learning target dataset, where it's basically just going to like save images into. You can feed that back into your training pipeline, retrain your models, and they will just get better over time. So this is also a pretty cool feature. But everything here, no code, and we will get the code snippet after we have created this custom workflow. So we have our model now. It's just going to do the inference. We will get the outputs. We will get a dictionary with our model. Then we can just take the key value, which is the prediction, and we will basically get our output. We can extract it, do whatever we want with it in code. But if you don't want to do the code, if you want to iterate fast, if you want to create some pretty cool stuff, we can go in. Either here, you can fork it, and then you can create like 2 separate pipelines going in parallel, or we can add a new element here or block. Could be that you want to do detection filtering. You only specify you're only interested in one specific class, for example, for one side of the pipeline. You can create another side of the pipeline that happens like if another class is detected. Let's say that we want to detect people walking around. Okay, maybe we trigger an alert if we see a person. Then we can send an alert either to Slack or the other different types of communication like email notification that was also available directly in here. You can also create your own custom blocks. But if we detect a person, it's going to send the email alert. If we detect animals and so on, probably just going to visualize it or something else. So we can have these separate pipelines. Instead of writing everything in code, connecting the outputs and so on, we can directly do it here in the workflows, and it works very good. After we have deployed our app, if you want to make changes, you can just go back here in the UI, make the changes, hit save, and it will automatically like instant update it, and you can just rerun your code and it will have the new changes. So let's just start very simple here. Now we're going to add a bounding box visualization. Just going to draw a bounding box around the detections that we're getting. Our input image here will be our image, and the predictions that we want to visualize with our bounding box visualization, it's going to be our predictions. We add a coupler image. We can specify what color palette we want to use, depending on like whatever. If you want to have your visualizations, your label and so on in a specific format, specific colors and so on, you can specify it in here. We can also choose how bounding box colors are assigned, if it's class assigned, index, or depending on if you do object tracking as well. If you want to do object tracking, I'll show you a quick tip here. You can just hit plus. Let's just search for tracker, by track, and now we have implemented object tracking on top of our object detection models, and now we will also get IDs. So if we get in here to our predictions, instead of just taking our predictions from our model, so now we can see it splits it into 2 pipelines because I just took this bounding box visualization, connected the output from the object detection model. Now I go back here again to track detection, and it's going to pull it back because then we're visualizing all the tracked objects that we have in our frame. So maybe just keep this object tracking here. Again, it's just going to track all the bounding boxes and so on top of our object detection model. I'm also interested in visualizing the labels. There we go. And we can specify what we want to visualize for our labels. Class, confidence, class and confidence, index, dimensions, area, or track ID. So right now we visualize our class based on color. So let's now just go in and specify our track ID for the text in our label visualization. That's it. That's everything that we have to do. And if we go into the output now, we can see that we can both take our predictions, we can take our label visualization. So if we take our results that we get back from our inference in our callback function that we're going to have, then we can just take our output, take the key value, label visualization, and we can show that with OpenCV. We have our model predictions. And we can also add another output here. We can select any output that we want to have. We can even see an example in here when we test out the workflow. There we go. Let's say that we maybe want to take our, could be that we want to take like all properties, or we only want to have our track detections, already seen instances. So if we are still like keeping track of the same objects, we can take our model ID, inference ID, or just all properties from this object detection model. So we're not really interested in that. We just have our model predictions and our visualizations. So this is actually like the wrong one because we want to have our track detections. There we go. So now we have a visualization image and we have our track predictions. So let's call it tracked predictions. Hit save. It's gonna save it here. We can either host it on the hosted API, so we can just test it out directly. Test the workflow here. You can drop in an image. Probably just pull out the webcam as we had before. So let's go in and run this application again. This is just going to run like with the other YOLO models out of the box. Just gonna open up the webcam, have it here. Let's just grab a screenshot, and I'll just throw the screenshot in here. We can now run our pipeline, and we should get our preview over here to the right with the JSON format that is going to output for every single frame that we throw through it. So here we get our output JSON. We can also like take the visualized. So right now we both have our track ID 1, 2, 3. The other bounding boxes are from the model that I just screenshotted. So you can basically just not look at those. We have our track predictions. I changed it from model predictions to track predictions in our output block, as we can see here, track detections. So this is why we have this key. We have our predictions, and we also have our label visualization with our image. This is pretty awesome. We can set up whole computer vision pipelines, drag and drop in this UI. Don't have to do anything, no code at all. Very nice structure. You can directly see it in here and test it out when it's running on the hosted API. You can also do a dedicated deployment. You can specify your name if you want to use CPU, GPU, development, or production environment. Local host if you have your own computer that you want to run Inference on. You just need to pip install the Inference CLI and also the Inference server start. I'm going to cover like way more in the future, so definitely like stay tuned for that. Whole playlist covering all the cool features from Roboflow, because we can use this for setting up whole computer vision systems. So we connect to the local host, it's just gonna connect automatically to it. Then when we run it in here, it's gonna use our own resources, and we can also do it on edge devices. So it supports real-time video, CUDA GPUs, all blocks running custom code. It requires Docker, but again, here you can have your server URL or local host. Right now, it's just running on hosted API. We've created a whole computer vision system. We now want to deploy it. We just press deploy here in the top right corner. We have a Roboflow hosted API, run on an image or run on a video local. So we just get the code snippet and what we need to install to be able to run this code. So just run it on a video. I'm just going to copy paste this code snippet. First of all, we need to pip install Inference. So make sure that you have that. Just close this application. Pip install Inference. Already have it installed on my computer. Let's go back. We will just grab this code snippet. Everything that is happening here is just we import Inference pipeline from Inference, CV2. We have MySync here, which is just a callback function that is going to use every time we get a response for our image. So we have init with workflow. We set our API key to start with, our workspace name. We have our workflow ID, video reference, so path to a video or 0 for a webcam. Specify the number of frames per second, max number of frames per second. Could be use cases where you only want to process 30 frames per second or the same FPS as your input video or stream. Then on prediction, it's gonna call this MySync function, and you can do whatever in here. You can store the results, you can use them for visualizations, you can use them for triggers, you can call other functionality in here, you can store them, you can have global variables and all that, but here is pretty much the main stuff. So I'm just going to grab this one here and put it into our test Roboflow. I will delete this API key here, so it doesn't really work. We have the API key, workspace name, have all of it down here at the bottom. Right now, we don't have our output image. If we go inside our workflow again, we can see the response that we have. So it's called label visualization. So I'm going to grab that instead. There we go. We're just going to import with OpenCV and also print the results. So when we print the results, it's just going to throw out our track predictions and also our predictions. With our track ID, we get our bounding box, confidence score, and also our class ID. So this is pretty cool. Now we can just run it. It's automatically going to set it up. So let's run Python test_Roboflow. We run it, should just pull the model. It open up the webcam. And here we're running our predictions. So it works pretty fast. Again, this is just running on CPU with this whole inference pipeline. It loads it in very fast, real-time performance, even on a CPU. We get all the outputs out at the bottom, all the IDs that we need, detection IDs, inference IDs. We have parent IDs, label visualization, which is the image that we are visualizing. And we also get our bounding boxes, track IDs, confidence scores, and so on as we're used to, and we can extract it over here. So if you want to extract like all the different things here. I'm going to create another video where I'm just going to take this result variable that is the output and just extract everything. So we just have for loops running through this result, storing it into separate lists and so on, so we can take our bounding boxes, classes, confidence scores, use them in our own applications and projects. We can build out custom workflows in here, custom blocks of code and so on, but at some point you need to take the results from this pipeline, connect it to other systems, or like build your software system around it, create an API around it or whatever. But you can do most of the work in here, even custom blocks if you want to create templates that you can use later on as well. But it's running pretty fast. We have our track ID. Even though I'm moving around, we still keep track of me with ID 1 and the potted plant in the background as ID 2. This is pretty cool. Let me just show you how fast it is to update it. So I'm going to terminate the program, go back into Safari. Let's now say, okay, we don't want to do object tracking anymore. Then we have to go in and take this one. We just take our model predictions, and here we just take our model predictions again. Have our output. We don't have our track now, so we just take our model predictions directly. Have our label visualization. We hit save. We can go up to deploy again, but it's just going to be the exact same code. Jump into cursor, rerun the application here, and now we will not run with object tracking. Now we can see no track ID. We can jump into our pipeline again. Label visualization, instead of track ID, we're just going to set class. Hit save. It's still running here, as we can see. Gonna terminate it. Rerun it. Just gonna spin it up, and now we should see our class IDs instead. There we go. Potted plant, person. This is so awesome. Like, you can save a ton of time by just using this whole workflow, the pipeline, the inference, and so on. You can see how fast it is. It's running with the threaded in the background. We're going to build whole systems around this, templates. You can have your own custom templates. It has the whole computer vision pipeline. Take your data set, label it Roboflow. They even have auto annotation tools. I have videos covering that as well, so definitely make sure to check that out. It's doing really awesome now, the video. Like, it's just going crazy now, my auto labeling tool, auto labeling video with Roboflow. So check that out. Just drop in your images, specify, prompt it, what do you want to actually like label your data with. Could be cars, persons, and so on. It's automatically going to do it. Wait a couple of minutes and you have a labeled data set. Then you can train your models. We're going to cover that, how you can train models in here as well with Roboflow. Upload your custom weights if you train somewhere else, and then do the whole pipeline in here. This is awesome. We're going to cover this way more in the future because this is so important. This is so valuable for computer vision engineers, machine learning engineers, and so on. You don't need any coding experience at all. Follow these guides. It's very intuitive, nice UI. We can then focus on building systems around it, focusing on getting the best models, like fine-tuning our data, trash in is trash out, fine-tune our models, get it out there, build software systems around it, act like solve business use cases. Because just taking your model, training it, doing fine-tuning, testing out different models, like training it, you can just train everything in parallel, test it out, extract the results, and so all those things are like just repetitive, boring things. We need to build software systems around it, and Roboflow, they have built this whole framework. I'm also going to build out like a whole Ultralytics playlist, Roboflow playlist, where I basically just have like 15 videos covering both frameworks in depth. Going to do comparisons, when to use what are the pros and the cons for the different frameworks. So definitely stay tuned for that as well. And then I'll see you guys in the next video. Until then, happy learning.